Hey everyone, and welcome back to this channel, or welcome to this channel if it's your first time here. I'm David Townsend. This is the Netcademy, where we are learning networks together. And a few weeks ago I started the ISIS, or intermediate system to intermediate system routing protocol, the subjects of the videos on this particular routing protocol, and I got to a certain point in that video where it was 15 minutes long. Now that's obviously a long time for any video, so I cut it, I stopped it, and now we're actually going to continue on with that video itself. So we're actually going to start building those layer 2 or level 2 adjacencies within that network. Now if you didn't see that first video, the link is down below. Check it out. I guarantee you, if you're new to ISIS like I am, it's going to be very informative. But not only in this video are we going to be concentrating on building those level 2 adjacencies in these different areas, primarily area 0, that backbone, but we're also going to concentrate first on those different ISIS packets, because just like OSPF and any other type of routing protocol like BGP, for example, they have different types of packets. With OSPF there are 5 type of packets, whereas actually with ISIS there's actually fewer packets, but there is a very interesting twist to these packets. And once we've gone through the different packets that ISIS actually uses, we're going to jump on the lab, build the adjacencies, and then use WireShark to go into and capture specific packets on the interfaces themselves and go into something called TLVs, or type length values. So stay tuned, this is going to be an interesting one. So let's get right into it and start with the ISIS, or intermediate system to intermediate system packets. I'm just going to call it ISIS for short. Now, just like with any routing protocol, there are hello packets. There is in the OSPF world, open shortest path first. The default for that is 10 seconds. ISIS has its own hello packets. So here we go here with our hello packets, and what these do is basically serve to inform whoever's on that remote end, obviously some kind of multi-layer switch or router, that I am an ISIS speaking router on this particular interface. It's sending out at a particular range of seconds, and it does vary. I'll come on to that in just a second, but it will send out hello packets at specific intervals to say, yep, I'm still here, I'm still here, I'm still here. Let's keep this link up, let's keep this adjacency built between this router and that router. That is the common functionality of a hello packet. But just like OSPF, ISIS will also inform within that hello packet what it is actually capable of. Now with OSPF, the default and the standard really is 10 seconds. Every 10 seconds an OSPF hello packet is sent out. With ISIS it is a little bit different, as I said. Now if it's a non-designated router, the hello packet for ISIS is sent out every 9 seconds, where if it's for a designated router, that hello packet is sent out every 3 seconds. We'll come on to the designated router functionality in the ISIS world in a later video, but right now let's just stay on this hello packet. Now there's actually 2 types of hello packets, and this blew my mind when I was actually learning about this. We've got here, both of these are IIHs. IIH, and what that stands for is intermediate system to intermediate system hello. That's basically it. IIH for short. And what we have is actually a IIH at level 1 and at level 2. Now if you watch that first video where I go into the basics of ISIS, and again the link is down below, you would have heard me say quite a few times that ISIS works really hard at keeping level 1 completely separate from level 2 and vice versa. And because this is a link state protocol, just like OSPF, we have a link state database for level 1 and a link state database for level 2. But that's not new, because you would have heard me saying that in the first video. But what is new, and this did blow my mind when I was learning about this, is that the adjacency is not built at level, or sorry, layer 3, where we look at BGP, ISIS, EIGRP. If you're coming from the Cisco world, everything is done at layer 3, at that IP layer. But for ISIS, regardless at the level, whether it be level 1 or level 2, these are all building the adjacencies at layer 2. Not level 2, but L2. I don't want you to get confused between L2, level 2, and layer 2, L2 there. But this is actually building the address using a specific multicast address. And just up here, I'm just going to put M for short because my face is in the way. The IIH, the hello packet for that level 1 building adjacency, is also using a multicast address. Now those multicast addresses are a bit different. And here are the multicast addresses for the layer 2 communication, but depending on if it be level 1, level 2, there's going to be a different type of multicast address. So if it's a level 1 multicast address, it's going to use this address here. So it's going to be 0180C2000014. The difference being between the level 1 and level 2 is right at the end here. So where level 1 ends in 14 or 14, the level 2 layer 2 multicast address ends in 15. Honestly, I had to look this up. I've never known that before. I'm probably never going to remember it again. But if you want to remember that kind of information, there you go. Those are the two different types of multicast addresses that you get at layer 2 depending on the level itself. So that is the hello packet. That is the first type of packet itself. But what is the second type of packet? The second type of packet is what's known as an LSP. I changed the color just to make it a little bit more different because I appreciate that's a green handwriting on a green background, so I changed it up a little bit there. But what does this actually stand for? This stands for Link State PDU, or LSP for short. Now if you know any type of layer 2 protocol like STP or RSTP, and there's quite a few others, you would have heard the term, especially in the STP world, Bridged Protocol Data Unit. ISIS, because it's building this communication at layer 2, it's using PDUs, the Protocol Data Unit, to exchange something called generic data structures. Now what is a generic data structure? Well, it's, as the name actually implies, it is a set of data that's built using a generic set of standardization or templates or configuration, however you want to think of it. Now in the ISIS world, these are done via TLVs, or type length values. If you don't know what these are, this is what ISIS uses, and it's what makes ISIS such a scalable and really incredibly future-proof routing protocol, because all we have to do is define a different type. So at first, the type is defining what is this type of data. Is it IP extensive reachability? Is it something to do with traffic engineering? Is it something to do with MPLS? It's defining that type of data itself. The length defines how long is that actual data that the generic data structure, i.e. those LSPs, actually carrying. And the V, the value, is really the value itself. So we define what is the type, what is the length of that information, and then what is the value of that actual information itself. Now in the OSPF world, there was nothing like this TLV, and that's why ISIS is so stinking flexible and so blooming future-proof. But what the OSPF did do is they actually released types 9, 10, and 11, I think they are, which are the opaque OSPF packet types, and they are using TLVs. So that is the second type. Now in the OSPF world, this would be known as the link state update, and I'll come on to that in just a second. But in equivalency, this would be the link state update in the OSPF world. But what is the third type of packet? So the third type of packet is called a CSNP, or Complete Sequence Number PDU. I know the P can make you think, sometimes I do that it's actually going to come in and say protocol, but it actually means PDU. But what is a CSNP? Well, there's actually two types of CSNPs. There's one at level 1 and there's also one at level 2. So just like hello packets, where we have hello packets at level 1 and level 2, we also have CSNPs at level 1 and level 2. The reason being is because we've got two different link state databases, one at level 1, one at level 2. And again, ISIS works really hard at keeping these levels completely separate. Now what the CSNP LSP does, and it's like that database description in the OSPF world, it's actually describing the contents of that level 1 or level 2 link state database. So it advertises out to a receiver router or receiver multi-layer switch. Hello, I'm here, I'm at level 1, I'm at level 2, this is who I am, this is what I'm capable of. Here is my CSNMP. This is one of the first packets he will actually send to describe what are the contents of my level 1 or level 2 link state database. It's informing that remote end what prefixes, what metrics, what sequences, etc. it has contained within its link state database. And this actually then comes on to that fourth packet. The fourth packet is what's known as a PSNP, or partial sequence numbered PDU. So when a device transmits a CSNP saying here's the contents of our link state database, that receiver who's receiving those CSNPs can check, do I have any missing entries? And then it will send, if it does have missing entries, missing prefixes and all the associated parameters, the metrics, the sequence IDs, the lifetime, etc. for those prefixes, it will send out a PSNMP, which is like the link state update in the OSPF world. And what it would do is it would send that out to that transmitter saying, hey, I am missing some information here. And then that device which has received this PSNMP, it will then send that link state PDU to that device to update its link state database. Now LSPs and PSNPs, they can actually be used, there's a little bit more detail here to actually acknowledge the receipt of information itself, but from a high level these are those 4 different types of packets. But what we're going to do now is we're actually going to go onto the lab, we're going to build some adjacencies, and we're going to start seeing these packets, going through these interfaces via WireShark and start looking at these type length values or that generic data structure. So here's the lab from the first video, the lab we're going to be using for quite a few videos moving forward as we learn more about RSIS and we get on to the more of the advanced topics. But as a quick recap, a quick refresher, what are we seeing here? Well, we're seeing 3 different areas. We're seeing area 1 here, area 0 and area 2. Now area 0 is that backbone, but unlike OSPF, that backbone doesn't have to be area 0. But for consistency, I just named it area 0. So all the connections in area 2 on this interface, and well, all these interfaces here basically, well these ones here I should say, are all going to be level 1. So the interfaces up to here and across, just to be more specific, are all going to be level 1. But all the interfaces here are going to be level 2 interfaces, because this is area 0, it's the backbone, it's there to provide the connectivity, the transport. And area 1 is going to be a bit different. We're going to have level 1s between these 2 links, or routers I should say, and also level 1 over here. But we're also going to have level 2 here as well. So between R2 and R3, this is going to do both level 1 and level 2. And on the last video, all we really done was, yes, a quick introduction into IS. Well, I say quick, it was 50 minutes, but we configured level 1 routing here, level 1 routing here, and level 1 routing here, and that was it. And that's where we're actually going to start, is we're actually going to start by configuring the level 2 routing, not over here, but actually on the R4 and R5 routers on these interfaces here. And there is a reason to that, because I want to show you when we build the connections here, the adjacencies coming up and going into those packets and obviously seeing those TLVs. And here we go on R4. So I've just logged into it. So if I actually go into CLI, the command line interface IE Junos, and I want to go into configure mode. But if I actually just do a quick run show ISIS adjacency, this is a great command because it will show you if there are any ISIS adjacencies. Of course there is not. ISIS is literally not running. That's what Junos has come back and told me. So let's configure these level 2 connections on the interfaces themselves. So let's do edit, protocols, ISIS, do a quick show, and again there's nothing there. So we want to set the interfaces out of the 4 interfaces here. So GigE002 to R2, GigE003 to R3, GigE006 to R6, and GigE007 to R7. Funny how that works. So let's do set interfaces, out of gigi 0, 0, 2, and this needs to be a level 2 connection. Now if you recall the first video, there was a disable command. Now because this is a level 2 connection, we want to say level 1 disable, so it's only going to work at level 2. If I wanted this to be a level 1 connection, I would say level 2 disable. And equally, if you wanted it to be both level 1 and level 2, you wouldn't say level 1 or level 2 disable, you'd leave that part as such completely blank. But let's just hit back up and let's now do it to R3 out of gigi 003. Hit up again, let's do it out of the gigi 006 interface to R6 and to R7. And let's do a quick show, and we can now see we have very quickly configured those interfaces to build that level 2 adjacency. But what I do want to do is just make sure that we've got that loopback address actually configured. Because remember from the first video, again the link's down below if you haven't watched this, we need that loopback address with that ISIS or ISO address to be advertised. That is that network entity that is very important in the ISIS routing protocol. So let's do top, let's just do show interfaces loopback 0, and it is not configured whatsoever, so that's why we obviously check these things. So let's do set interfaces loopback 0.0, and you can actually see I've got the R4 INET address just down here, so that's why I wrote it there. And now I'm going to say family ISO address 49.000 because that is the area, 172.168.0.004.00, and that is the ISO address for the loopback 0. Now if I do show command, we can now see that ISO address. But if you also recall from the first video, we also need to define the interfaces to be speaking family ISO. So we need to configure that. So let's do set interfaces gigi 002 family ISO, gigi 003 family ISO, and gigi 006 family ISO, and gigi 007 family ISO. Now if I do a quick commit, now I'm not going to see any adjacencies right now, even though that configuration has been committed, because I have not built the adjacencies, or even the connections I should say, the settings on the other routers that are connected to R4. So now I'm going to go across to R5 and really do the same thing. So I'll show you this one, but I'm not going to show you this for every single router because you're going to get bored and you're no longer going to watch this video. So let's go over to R5 and let's go to CLI configure, spell it right, it's obviously always a good thing. And let's do set protocols ISIS interface. This is going out of the gigi 002 interface to R2, and I want to say level 1 disable. And I also want this to go to R3 level 1 disable, so it's going to be a level 2 connection to both of these routers. And I also want this to go out of the gigi 006 to R6 and gigi 007 to R7. And let's just do a quick show interfaces loopback 0, and there's nothing still configured there, so let's do set interface loopback 0 family ISO address 49.000.172.168.0.005.00. And now I've set the interfaces, all of them, to speak the ISO language. So gigi 002, gigi 003, and gigi 006, and last but not least gigi 007. And commit this configuration, and that is now committed. So that is very quickly how we use the Junos to build a level 2 connection. Pointing out of an interface, again you need that loopback 0 configured, absolutely. We also need that interface to speak family ISO, or International Organization of Standardization, if I remember correctly. And obviously we need to define the protocol itself to look or point out of those interfaces. So now I'm just going to configure R6, R7 and R8. I'm not going to show you this, but I will obviously come back when it is time to configure for level 2 those interfaces between R2 and R3 and those routers into area 0. Okay, with all these other routers configured now, so I've configured R6, R7 and R8, we're ready to go with the rest of the configuration on routers R2 and R3 to build that level 2 adjacency to one each other, but also up to R4 and R5. And the end goal is to see, can R1 ping all the way through this to R8, and what does it actually see in its routing table? And of course we'll go into those TLVs. So let's go on to R2. Oh, and I should mention as well, I didn't mention it in the past, in just now, but here you can see I've actually added in the INET addressing that I'm using for these interfaces. You didn't see me configure those just now, but I assure you they are there, otherwise IP reachability really would not work. All you have to do is see my last video to see why that is actually the case. But I'm on router R2 and let's go into CLI. Not CI, CLI. And if I just do a quick show ISIS adjacency, this is one of the commands, and you can see, and I love this, it actually picks up the host name of router R1, and out of the Gigi 001 interface, this is a level 1 connection, and it's been up for a certain amount of time, state is up, and here's the MAC address of the remote end. That's basically what the SNMPA actually stands for. It's something like sub network partition address, something like that, but it's the MAC address basically of the remote end. And we can also do other commands such as show ISIS database. Now, what we can see here is the database for level 1 and level 2, but obviously there's nothing really in, well there is actually, it's probably a bit of a rogue one here, but here we can actually see the link state database for level 1 and level 2. Now when we configure the R2 and R3 interfaces to be a level 2 connection to each other, also up to R4 and R5, this is going to change ever so slightly, and let's actually do that now. So on R2 we can see we've got all these interfaces here, so let's just go into configure mode and let's do show protocols ISIS. So we can see we're pointing out of the Gigi 001 interface and out the Gigi 003 interface, but we don't have the Gigi 004 to R4 and Gigi 005 to R5 actually configured. So we need to obviously define that. So let's do set protocols ISIS interface Gigi 004.0, and this is going to be a level 2 connection, so we're going to say level 1 disable, and we want to do the same for Gigi 005. And now if I do a quick show, we also, oh I've gone too far, let me do show protocols ISIS. We also want to change the interface in terms of the level between routers R2 and R3, because you can see here it says level 2 disable, which implies it's just a level 1 connection, whereas we want it to be level 1 and level 2. So we need to delete protocols ISIS interface Gigi 003 level 2 disable. And if I show protocols ISIS again, we can now see that the interface to R3 is going to be both level 1 and level 2. But let's actually make sure we've got the INET addressing configured on the interfaces themselves. So let's do show interfaces Gigi 003, and it is configured there. Do we have it on the interface to Gigi 004? Yeah, we have got ISO but not the INET address in, and Gigi 005, so obviously we need to change that. So let's do quickly set interfaces Gigi 004.0 family INET 200.10.20.42/30. Just do address, and let's do the same on Gigi 005, and let's now commit that configuration. Now let's move on to router R3. Now what I'm going to do is, before I actually hit commit on this, is I'm going to go into WireShark, because I'm just going to build the configuration, but I want to show you those packets. So let's go into CLI, configure, let's edit the protocols ISIS, do a quick show, and as we can obviously guess, we need to set the interface to go out of Gigi 004, and this needs to be level 2, so we're going to say level 1 disable, and the same again for Gigi 005, but we also need to delete the interface Gigi 002 level 2 disable, do show, and that looks absolutely perfect to me. So we've got all the level 1 or level 2 connections etc. going to where they actually should be. And let's go top, edit, interfaces, let's do set Gigi 004.0 family INET address 200.10.20.46/30, and let's do the same for Gigi 005 family INET address 200.10.20.53/30, and let's just do a quick show, make sure the interfaces are configured correctly, and they absolutely are, so we can see the interfaces here. And let's now run this configuration, but before I do so, before I go too far, let's get that WireShark up. So let's just move this out the way, and I'm going to run a WireShark on the R2's interface. So let's do capture on Gigi003, and let's maximize this. You can already see some packets going through, but if I just drag the thing back over and let's do a quick commit on this, and in the background we will see some hello packets, etc. So we can already see all these hello packets at level 1, at level 2, etc. There's a level 2 packet right there. We can see LSPs. That's probably more than enough packets, to be honest. So let's actually do a stop and let's just maximize this a little bit more so we can go into those TLVs. So here we go. So here's a packet capture. Let's just minimize this, and we don't want to go into all the bits and bytes, so let's just drag that down here. So here we go. Here we've got a level 1 hello packet, and we could see it's using the 802.3 format, so it's going to have an LLC or logical link controller, and in here you can have DSAPs and SSAP addressing, but what we really care about is the ISIS hello. So here we can actually see, is it a designated router? We can also see what protocols it's supporting. Now these are actually all the values that are pretty much indicated for every hello packet. Obviously they're going to vary from device to device, but here we could see what is the address. So if I actually expand out here, we can actually see that part of the net address. So this is a 49. That is just the address family indicator for ISIS, and then it is in area 10001, and this is actually a TLV because we got the type, we got the length saying this is 4 bytes, and it has this value. This is a TLV for the address. We also have a TLV for the IP addresses, so we can actually see what is the IP address associated to that interface on the remote end, of course. So this is a hello packet at level 1. At level 2 it's really no different, except it's a level 1 or a level 2 hello packet. And we can also, if I scroll down, I think there was a LSP at some point. Here we go, actually here. So in the LSP, the link state PDU, not protocol, and here are actually a lot more information in those generic data structures in the TLVs. So here we've got the intra-domain routing information, so big word there, but we can see some TLVs again here. But if I scroll down now, we can actually see a lot more TLVs. So we got the area addresses, we got the originating neighbor, IP interface addresses, host names, IS reachability, extended IS reachability. The difference being is IS reachability, because we're looking at this from R2, IS reachability is who's connected directly to me, whereas extended IS reachability is who's connected to those that I'm connected to. So it's extended, i.e. because we're looking at packets from R3, we're seeing, well, who's actually connected to R3 in a TLV type of structure. And we can also see what are the router's capabilities as well. So there's a lot of information that we can get from TLVs. But right here we can see the hello packets at level 1, level 2. We could see link state PDUs, and we can also see just here the complete sequence number PDU, if I remember it correctly. So here we actually got the CSNP, which is when R3 is describing to R2 what is inside my link state database and all the values, metrics, etc. associated to that. So we've got the network built. So if I actually go on, and just to prove that, if I actually go into R2 and if I do run show ISIS adjacency, we can see that we've got to R1, R3, because don't forget we've got level 1 and level 2 connection to R3, and R4 and R5, we have got these level connections and all of them are up. That is absolutely perfect. Okay, I can also, just from R2, I can ping, just to run ping 8888, which is the inet address of router R8. But if I do a run show ISIS route, we can see all the routes within area 0, within area 1 and area 2. Really all the routers, or ISs I should say, in that backbone area, whatever it may be, area 0 in this case, but again remember it doesn't have to be area 0. It has complete visibility unless you're doing some kind of summarization or filtering of routes. It's going to see absolutely everything, and I can see router R1, R3, R4 and R8. I don't know why R2's not C because this is R2. Nearly got me there, I was wondering there. But it sees absolutely everything, of course. But how does this then compare to the routers which are in the non-backbone area? In this case, let's look at it from R1's perspective. So going on to R1, if I do CLI, and let's actually just do that same. So let's do show ISIS adjacency. So we've only got the two adjacencies, both level 1 to router R2 and R3. Now if I do that show ISIS route, then we do not see anywhere near as much as these backbone routers. We could see the INET address of the loopback 0 on R2 and R3, but we do not see R8, we do not see R5, 6, 7, R4, R3. We only see R2 and R3. In that case, can we actually ping from R1 all the way to R8? Let's give it a test, ping 8888, and we absolutely can. Why is that? It's because we have got this default advertisement here, this 000.0/0, this default route. Now this is actually coming from both routers R3 and R2, and this is very similar to the OSPF totally not so stubby area where that ABR was injecting into that backbone router a default route, i.e. 000/0. And so let's put this into perspective. We've got all these routes here. Say R1 had a route connected here and another route connected here, and so on and so forth. Lots of different routes. These routes would be advertised up to R3 and up to R2. They'd also advertise these routes to and from each other using that level 1 connectivity. And what these do, because these are still ABRs, is that they would inject and advertise these routes from router R1 that they've learned into this backbone area that is area 0, and these would then go all the way through the network. There's obviously quite a few paths here and I'm not going to draw them all out, but these would be advertised throughout that backbone area. But when they get to these ABRs here, they're then injected as a default route into that other non-back area, in this case area 2. So the backbone sees absolutely everything. Again, unless you're doing route summarization, route filtering, etc., it will see everything, or it should do, hopefully. But when we are then advertising those routes back into another non-backbone area, which is in the originating area, so into area 2, it's advertised as a default route. That is just the rule set. Go back to the previous video, it's mentioned there, that is the rule set of ISIS. And it's just hit up a few times just to clear the screen. But now let's actually see that link state database. So if I do show ISIS database, here's what's changed from a few minutes ago. We can actually see attached now, attached here. So router R2, and again it's picking up on the host name. That's really cool because it's just saying, yeah, it's router R2, yeah, it's router R3. Yeah, we can see the sequence and the checksum and the lifetime, etc. But it's saying attached. So router R3 and R2 are attached. What that means is they are attached to that backbone network. They're advertising in that default route. Both of them are advertising in those default routes. Obviously you might want to do some metric tuning, some cost tuning, etc., because they're both going to be advertising in that default route as the same, and as such R1's got two paths to essentially get to the same destination, whatever it may be. But this is how ISIS fundamentally and default actually works. So that's the end of this video. I hope you found that useful. We've gone through a lot of information, such as what are those different ISIS packets, the hello, how that operates at two different levels using two different multicast addresses. We've gone through the PDUs, the generic data structures, how they use TLVs and why it's significantly more beneficial than what OSPF actually does. Then we've got the CSNMP and PSNMP. Now that was high level. There's a lot more detail into how those packets, specifically the PSNMP, can actually be used to actually acknowledge, like the LSA type LSA ACK in the OSPF world, how that can be used to actually acknowledge those database descriptors or those PDUs in the ISIS world. And then we went through how to actually build that level 2 adjacency in that backbone and seen those packets in that WireShark and a few shell commands at the end, and we could see that default route being injected into those non-backbone areas, and how that R1 router was able to ping all the way through R8, and what it actually sees in its routing table and its link state database. So I hope you found that useful. If you like this video, please like it, please give me a comment. I love hearing from you guys, and stay tuned for the next video where we're going to start going into mesh groups and maybe some route filtering, route summarization. So a lot more detail to come. Thanks for watching and goodbye.